All of the known elements and their information are listed in a table known as the periodic table. The chemical symbol for any element consists of one or two letters, with the first letter capitalized. For example, the symbol of sodium is Na. The symbol of chlorine is Cl. The symbol of sulfur is S. Atomic number, which is number of protons or electrons, is written as subscript, and mass number, which is the total number of protons and neutrons, is written as superscript. Sodium atom has 11 number of protons or electrons because the number of electrons must equal the number of protons. Because neutral atoms have no net charge. To calculate number of neutrons, subtract mass number from atomic number. So sodium atom has 23 minus 11 equal 12 neutrons. Actually, average atomic mass, which is average number of protons and neutrons, is written in the periodic table, not the mass number, because elements occur in nature as mixtures of isotopes. Isotopes are atoms with the same number of protons but different number of neutrons. Isotopes can be represented by two ways. First, by removing the atomic number because all atoms of a given element have the same atomic number. For example, sodium atoms are represented as 23 Na. Chlorine atoms are represented as 35 Cl. Sulfur atoms are represented as 32 S. Second, writing the mass number after the element name. For example, sodium atoms are represented as sodium 23. Chlorine atoms are represented as chlorine 35. Sulfur atoms are represented as sulfur 32. Average atomic mass is known as atomic mass or atomic weight. Be careful that mass number is number of protons and neutrons if an element contains atoms with the same number of protons and same number of neutrons. However, atomic weight is the average number of protons and neutrons if an element contains atoms with the same number of protons but different number of neutrons. For example, mass number of sodium element that contains only atoms with the same number of protons and same number of neutrons is 23 AMU. However, for the atomic weight explanation, suppose that naturally occurring sodium is composed of 75% of 23 Na and 25% of 24 Na. The masses of these isotopes are 23 AMU and 24 AMU, making the atomic weight of sodium 0.75 multiplied by 23 AMU plus 0.25 multiplied by 24 AMU equal to 23.25 AMU. Consider carbon element that consists of many carbon atoms, each carbon atom represented by C612. This means that each carbon atom consists of 6 electrons, 6 protons, and 6 neutrons. The overall representation of this element is C612. This number is the mass number. Also consider carbon element that consists of many carbon atoms, each carbon atom represented by C612 and C613. Which known as carbon-13. This means that the C612 atom and the C613 atom, each of them consists of 6 protons and 6 electrons. However, the C612 atom consists of 6 neutrons and the C613 atom consists of 7 neutrons. The C612 atom and the C613 atom are called isotopes because they have the same number of protons but different number of neutrons. The overall representation of this element is C612.01. This number is atomic weight, which is calculated from the masses of carbon isotopes and their relative abundances. To understand how to calculate the atomic weight of an element from isotopic abundances, determine the number of subatomic particles in atoms, and writing symbols for atoms, try to solve the upcoming problems. Naturally occurring chlorine is 75.78% of 35 Cl and 24.22% of 37 Cl. Calculate the atomic weight of chlorine. These numbers refers to isotopic abundance of each isotope, and these numbers refers to mass number or atomic weight if there is 100% abundance of each isotope.
We can calculate the atomic weight by multiplying the isotopic abundance of each isotope by its atomic mass and summing these products. So we have atomic weight equal to 0.7578 multiplied by 35 plus 0.2422 multiplied by 37 AMU. So the atomic weight will become 35.5 AMU. This answer makes sense because the atomic weight, which is actually the average atomic mass, is between the masses of the two isotopes and is closer to the value of 35 Cl, the more abundant isotope. How many protons, neutrons, and electrons are in an atom of 197 EU and an atom of strontium 90? Because 197 is a superscript, it is the mass number. According to the list of elements given on the periodic table, gold has atomic number of 79. Consequently, an atom of 197 AU has 79 protons and 79 electrons, and 197
is the number of protons and neutrons.
So 197 minus 79 equal to 118 neutrons.
This is the mass number of strontium.
The atomic number of strontium listed on the periodic table is 38. Thus, all atoms of this element have 38 protons and 38 electrons.
The number of 90 is the number of protons and neutrons.
The strontium 90 isotope has 90 minus 38 equal to 52 neutrons. Magnesium has 3 isotopes with mass numbers of 24, 25, and 26. How many neutrons are in an atom of each isotope? Write the complete chemical symbol for each. Magnesium has atomic number of 12. So all atoms of magnesium contain 12 protons and 12 electrons.
The superscript in each isotope is the number of protons and neutrons. For the first isotope, the number of protons and neutrons is equal to 24. So 12 plus the number of neutrons equal to 24. So the number of neutrons is equal to 24 minus 12 equal to 12. For the second isotope, the number of 25 is equal to the number of protons and neutrons. So the number of neutrons is equal to 25 minus 12 equal to 13. For the third isotope, the number of 26 is equal to the number of protons and neutrons. So 26 is equal to 12 plus the number of neutrons. So 26 minus 12 equal to the number of neutrons. So 14 is the number of neutrons. From this answer, we conclude that the number of neutrons for each isotope is 12 and 13 and 14. This answer is right because the isotopes are elements that have the same number of protons and different number of neutrons.
The chemical symbol means that we have to write superscript and subscript for each element.
So these are the chemical symbol for each magnesium isotope.